Welcome to the Math 1 lesson summary video for the task form follows function. This is a practice understanding task, and the purpose of this task is to develop fluency writing linear and exponential functions in all their various forms. And so that entails being able to choose the correct form of each type of function and also to be able to determine whether a linear or an exponential function is most appropriate. So we want to get confident with deciding which type of form to use based on the information given in the problem. So for this video, I'm going to go in a little bit of a different fashion. I'm going to go a little quicker because there's a lot of examples I want to get through. So first off, we have slope-intercept form, and that's y equals mx plus b, where m is the slope and b is the y-intercept. So as the name indicates, we want to use this when the slope and the y-intercept, so when it says intercept, it's specifically talking about the y-intercept, are clearly given from the problem. So if we go down to the problems of this task, number one is the scenario that fits that case. It says, in his job selling vacuums, Joe makes $500 each month plus $20 for each vacuum he sells. Write an equation that describes Joe's monthly income. So his base pay of $500 each month is the y-intercept of the scenario, and then the $20 for each vacuum that he sells is the slope of the scenario. So instead of y and x, I'm using I and n, so I can write I equals 20n plus 500. And that's a scenario where slope-intercept form is most appropriate because the slope and the y-intercept are clear from the description of the problem. Now let's consider another form, point-slope form, which we learned about in the lesson. So as you can also tell from its name, point-slope form is most appropriate when you have the slope and a point. So x1, y1 are the coordinates of a point on the line, and the form is y equals m times x minus x1 plus y1. And remember, this minus here really just indicates doing the opposite of the x coordinate in the point. So if I go down to problem 2, it says write the equation of the line with a slope of -1 through the point -2 comma 5. So since it says slope and a point, I want to use point-slope form. So it's going to be, so I'll write it again, y equals m times x minus x1 plus y1. So this is my m, this is my x1, this is my y1. So it would look like y equals -1 times x plus 2, because remember that minus we think of as meaning opposite, and then plus 5. And that would be the equation in point-slope form for that problem. So next up we have the recursion formula, or the recursive formula for a linear function. And so that is f of n equals f of n minus 1 plus d, and d is the common difference or constant difference as they're calling it here. This is used only for discrete functions. And it turns out there's not a problem in this task where the recursion formula for a linear function is most appropriate, but you did tons of those back in Math 1 Module 1, so hopefully you feel confident with those. Alright, moving down now to exponential functions. So we have the explicit form of an exponential function, y equals a times b to the x power. And so let's look for a scenario where that's going to be the most appropriate form to use. So here we have one, problem 4. The population of the resort of Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. So we know we're using the form y equals a times b to the x power. A is the starting value, so in this case that's 35,000. And b is the growth ratio. When we have a percentage, we want to use 1 plus or minus r for b when it's based off a percentage. And in this case, we specifically want to use 1 plus r because it's increasing. So 1 plus 0.024, which is 2.4% as a decimal, is 1.024. So we now have the equation. Instead of y and x, it says t is the number of years, and we're talking about the number of people. So I'll use p. So we'll have p equals 35,000 times 1.024 to the t power. And that would make sense for the scenario. Now, I'm not going to do this for every problem. I didn't do it for the first two examples, but you'll want to think about the answers to these questions. So again, the form of this function is the explicit form of an exponential function. It's exponential, and this is going to be a continuous function because the population is continuously growing. There are people being added to a population daily, every second, through births and moving and stuff like that. So another form very similar to the explicit form is called point ratio form. And so that's just saying if I have a further point along the graph, then we can make an adjustment. So these are actually equivalent equations. If you graph them, they would be the same. So this is saying we're starting at 10, we're multiplying by 3. So if I was to make a table for this, just a quick little table, x and y. So when x is 0, y is 10. When x is 1, y is 30. So this is saying when I base my starting point 30 off of the n equals 1, or x equals 1 in this case, then I have to do the x minus 1 adjustment. And it could also work the same if I kept going. If I started it off of 2, and then that would be 90, I could write another equivalent rule, which would be y equals 90 times 3 to the x minus 2, and so on. So point ratio form is just explicit form, but when you're not starting from the y-intercept, but you're starting from some other number, like 2, then you have to make an adjustment in the exponent. And so finally we have the recursion formula for an exponential function, f of n plus 1 equals r times f of n, or as we've more commonly seen it, you could also say f of n equals r times f of n minus 1. Not sure why they chose to write it differently for this one, but we've done that a lot back in Module 1 as well. So a scenario where that would be most applicable is in problem 3 here. It says write the equation of the geometric sequence with a constant ratio of 5. So in that formula, f of n equals r times f of n minus 1. Well, there's our r is 5, and the first term is negative 3. So we're going to use the recursion formula. So that's going to look like f of n equals 5 times f of n minus 1, and f of 1, the first term, equals negative 3. So this, of course, is an exponential function. It's a discrete function because recursion formulas are only used for discrete functions. And so that should help get you started and get you the basic understanding you need for this lesson. Try to finish the other problems that remain. And if you need help with the Ready, Set, Go problems, please check out the Ready, Set, Go videos, support videos in Canvas.